This is geometry homework. This is for day 11. This is page 485. Question number 1 asks, to solve a right triangle means to find the measure of all of its angles and sides. At the end, you should know all 3 sides and all 3 angles. Here we are with number 4. We're going to use a calculator to approximate the value of angle A. So we know that from angle A, the opposite side and the adjacent side are given. So we're going to say that the tangent of A equals the opposite over the adjacent. Now we're going to solve for A. To solve for A, we need to use tangent inverse of 10 over 22, which is going to come out to an approximate value. We do second or shift, tangent, use parentheses. It's a requirement to use the parentheses so it calculates right. And tangent inverse of 10 divided by 22 is 24.44. 24.44 degrees. And the measure of angle A is 24.44. Angle A, the side opposite, the side adjacent. So again, we're going to use tangent of A and have that equal to the opposite over the adjacent. So we're going to need to use tangent inverse of 14 divided by 4 to give us the approximate value of A. So we say tangent inverse of 14 divided by 4. So we get 74.05 degrees. So for number 6, if we're still finding the measure of angle A, we're looking at the opposite side and the hypotenuse. Now remember the concept of SOHCAHTOA. That's going to help us identify which trig function we're going to use. Often students have troubles identifying the correct trig function, and this word SOHCAHTOA can help you identify which is correct. From angle A, we look at the opposite and the hypotenuse. We're not dealing with the side next to angle A. So opposite and hypotenuse, the OH. We have A and H, O and A. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we're dealing with the opposite and hypotenuse, so we're going to use sine. So sine of A equals the opposite side over the hypotenuse. We're going to calculate with sine inverse what the value of the measure of angle A is. And with our calculator, we'll say sine inverse of 5 divided by 11, and that comes out to be 27.04. That's an approximate value for angle A. Here we have angle A. So opposite is across from it. Well, we're not dealing with that number. That side. Hypotenuse is always across from the 90. And the adjacent is next to. So we know using SOHCAHTOA that cosine is adjacent over hypotenuse. So cosine of our angle A The adjacent side is the 6, and the hypotenuse is the 10. We want to know what the value of A is, so we're going to do cosine inverse to get the A value by itself. So we do cosine inverse, got to use parentheses to figure out that we have 53/13. For number 10, we're going to solve the right triangle. To solve for a right triangle, we have to find the missing sides and the missing angles. So the information we're going to be looking for is the measurement of angle K. We want to find out the length of ML. And we also want to figure out the length of KL. So to figure out the measure of angle K, we can say that the acute angles of every right triangle are complementary. So we know that the measurement of angle M plus the measurement of angle K has to add up to 90 degrees. So M is 40. So if we subtract the 40 to the other side, we know that the measure of angle K has to be 50 degrees. ML is the adjacent side to the 40, and the 8 is the hypotenuse. So using the idea of SOHCAHTOA, we're going to get the adjacent over hypotenuse. We're going to use cosine of 40 degrees equals the adjacent side, which is ML, over the hypotenuse, which is 8. We place the cosine of 40 over 1 because now we're solving for a side. That gives us 8 times the cosine of 40. And when we calculate that out, 8 times the cosine of 40, we're going to get 6.13. Next, we're going to look for KL. KL is the side that's opposite the 40. We still have the hypotenuse. So now we're going to use opposite hypotenuse using SOHCAHTOA, that's sine. Sine of the 40 equals the opposite side over the hypotenuse. Cross multiply. So sine of 40, 8 times the sine of 40, gives us 5.14. So for number 12, we're solving this right triangle. We can solve for the measurement of angle T by saying 90 minus 57. That gives us 33 degrees. Now from the 57, the 15 is considered your opposite side. RT is considered your hypotenuse because that's across from 90 degrees. And RS is considered your adjacent side. So using SOHCAHTOA, we know to find the adjacent side, RS, we have to use the 15 because that's one of our number values. So opposite over adjacent, that's tangent. So tangent of 57 equals opposite over RS. We'll cross multiply. That'll give us RS times the tangent of 57 equals 15, and we divide by the tangent of 57. So 15 divided by the tangent of 57. So RS is approximately 9.74. To figure out the hypotenuse, which is RT, we're going to use opposite hypotenuse, which is the sine of 57 equals the opposite over RT. Cross multiply. Divide by the sine of 57. So RT is approximately 15 divided by the sine of 57. $17.89. So for number 13, we're still solving the right triangle. We're going to look at this, and I see 9, 12. I see that 9 is made up of 3 times 3, 3 times 4, and 3 times 5. 3, 4, 5 is a Pythagorean triple. So this is a multiple of 3 for each one of those numbers. 3 times 3, 3 times 4, 3 times 5. 3, 4, 5 makes a Pythagorean triple. So I know that AC is 15. Pythagorean triple. 3, 4, 5. So we're going to say 3 times 5 equals 15. That equals AC. So I've shown some work on where that came from. Next, to figure out the measurement of angle A, I'm looking at the opposite and I'm looking at the adjacent. We've talked about SOHCAHTOA before, and opposite over adjacent is tangent. Tangent of A is the opposite side over the adjacent side. Now we're trying to figure out the measurement of angle A. We know the sides, so we're not ready to cross multiply. We actually have to use the inverse function. So tangent inverse of 9 divided by 12 is going to be 3687. That's an approximate number. You could use a little squiggly sign. 3687 degrees. So that's going to be true for every 3, 4, 5 triangle. This is a multiple to make it bigger, but the angles always stay the same. So now the measurement of A, of angle A, plus the measurement of angle C, we know make 90 degrees. So if A is 3687, I know that I'm going to subtract so the measurement of angle C is going to be 90 minus 3687. Gives me 53.13. So for number 14, again, we're going to solve the right triangle, so that means we're going to find the missing sides and the missing angles. Right now, I could use Pythagorean Theorem to find that missing side. Hypotenuse squared equals leg squared plus leg squared. The hypotenuse is 9. The leg is 3. And EF is another leg. So 81, 9, and EF. So subtract the 9 and we get 72. Take the square root of 72. And that gives us EF, which is, we could reduce that and leave it in radical form. That'd be excellent. But here we have 8.49. The directions here said round to the nearest tenth. So that would be 8.5. Okay, now to find the angle measurements, I'm going to use the information that they have right in front of us. So from angle D, I'm going to use adjacent over hypotenuse, which is cosine. Cosine of D equals adjacent over hypotenuse. So then we're going to use cosine inverse of 3 over 9. So cosine inverse, you've got to use parentheses, comes out to be 70.53. So that's 70.5 degrees. And then 90 minus 70.53 is our angle F. So 90 minus this answer comes out to be 1947. And that would also round up to 0.5. So here we're trying to figure out the measurement of angle A. We know that sine of some angle equals 0.75. So we're going to do sine inverse of 0.75, and that's going to give us the measurement of angle A. So like we've done before, we'll say sine inverse. I like to use parentheses. You don't really need it for a decimal, but you definitely need it for a fraction, so make use of doing it. So this is 48.59. They say to round to the nearest tenth. So 48.6. That's approximately the measure of angle A. Cosine inverse of 0.64 equals the measure of this angle A. So cosine inverse of 0.64 equals 50.2. That's approximately the measure of this angle A. So the tangent inverse of 0.28 is the measure of this angle A. So tangent inverse, 0.28, gives us 15.6 degrees, is approximately the measure of this angle A. So our next question is number 34. A soccer ball is placed 10 feet away from the goal, which is 8 feet high. So the goal is 8 feet high. You kick the ball and it hits the crossbar along the top of the goal. What is the angle of elevation? The soccer ball is 10 feet away from the goal, and the goal reaches up to 8 feet high. So for our number 34, if the ball is placed 10 feet away from the goal, and the goal is 8 feet high, we're supposed to figure out what the angle measurement is. We're going to use inverse. This is your opposite side compared to the angle we're looking for. This is your adjacent side compared to the angle. So opposite over adjacent. The tangent of K equals the opposite over the adjacent. So tangent inverse is 8 over 10, which is supposed to be the measurement of angle K. So using our calculator, tangent inverse of 8 divided by 10 gives us 38.66 degrees. Last question is number 38. For this question, we're standing on a plateau that's 800 feet high. Above this basin, you can see two hikers. If the angle of depression from the site to the hiker at B, the angle of depression, is 25, how far is the hiker from the base of the plateau? So going straight down, what is this length? So we know that we're 800 feet high. The angle of the angle of depression, they said, is right here, which is 40. Actually, it's 25 degrees. Now, if the angle is 25 degrees here, then we know alternate interior angles would show that this angle is also 25 degrees. We're looking for how far B is from right underneath the plateau. So to calculate that, we're going to look at the opposite side. We're going to look at the adjacent side. And using the concept of SOHCAHTOA, we see that opposite and adjacent is tangent. So we're going to use tangent of 25, and that equals our opposite side over the adjacent side, which is represented as x. Cross multiply. Divide by the tangent of 25. So using our calculator, we're going to get 800 divided by the tangent of 25. So we get 1,715.6. 1,715.6 feet. Part B says if the angle of depression from your line of sight to hiker C is 15, how far is the hiker from the base of the plateau? So here, for part B, we have an angle of depression from the sight line, and that's 15 degrees. We know alternate interior angles makes this 15 degrees. Here's point B. Person C is further from the base of the plateau. So we're looking for the value of y. It goes all the way from right underneath it to point C. So again, we're looking for y. We have the opposite side here, and we're looking for the adjacent side. So to calculate that, we'll use tangent of 15 degrees equals the opposite over the adjacent, which is y. Cross multiply. Divide by the tangent of 15. So the tangent 800 divided by the tangent of 15 gives us 2,985.6. For part C, we're supposed to find out how far are the two people from point B to point C. We know that point B was our x value, which was 1,715.6. Point C was a y value, 2,985.6. So to figure out the distance in between, which is like this value z, we know that the z value is going to be equal to this total value minus the little bit extra. So the distance between them is going to be 2,985.6 minus 1,715.6. So using our calculator, we will take 2,985.6 and subtract 1,715.6. 1,270. The people are 1,270 feet apart.